Hi everyone, welcome back. What happens if you're doing a polynomial long division and one of the letters is missing? One of the terms is missing. So if you look at this question here, a lot of people will jump in and go x into x cubed. I'm not talking about BMS, divide, multiply and subtract. So you're going to go through that pattern and they don't pick up and they don't realise that this is an x cubed and that's an x to the 1. So the x squared is missing. So what do? You need to put the x squared in. If I wrote that as x plus 3, and I put the x cubed and I put 0x squared, just to keep it organised in columns. You could do it if you're really good at it, you don't need this, but remember this is for the people, mostly for the people who are not confident with it. So first thing we do is divide, so x into x cubed goes x squared, and I still worry that people don't know, but you're going to see the same thing over and over again. X into x cubed, that's x to the power of 3, that's x to the power of 1. What do you do with the powers when you are dividing? You subtract the powers, so that's x squared. So now go divide, now we'll do the multiply. Remember please, you've got to do the multiply by everything. If you don't do the multiply by everything, it just doesn't work. X squared by the x is x cubed, x squared by the 3 is 3x squared. And I'm laughing to myself because I can see some of my students watching go, how do you explain, how do you justify that you've got to multiply by both of them? The simplest annoying math teacher's answer is because it works. When you don't, it doesn't work. That's annoying. So then I put the subtract. I still like to put a different coloured pen, go to a red pen. And I go x cubed, take x cubed is gone, so I don't have to write 0. 0x squared minus 3x squared is minus 3x squared. Please be careful that you get that negative that's just there. So many people leave it off and make mistakes and then get into a mess. We're back to divide. So we've just done the divide, multiply, subtract. So we'll do another divide. So this time it's x into minus 3x squared. So x into minus 3x squared. And again, one of the x's will cancel, or you can go 2 take 1 is 1. So that's minus 3x. 2 take 1 is 1. And you've got the minus 3. So x into minus 3x squared is minus 3x. My brain looks at it and all it does is remove one of the x's. So I go back to here, remove one of the x's and I get x squared. Remove one of the x's and I get minus 3x, which is nice and simple. So then what do I do next? Then I've just done the divide, now I have to do the multiply. Minus 3x by that x is minus 3x squared, and of course they end up the same. Minus 3x by 3 is minus 9x. Then I go back to my red pen for the subtractions. Oh my goodness. I see so many students who don't put that down, then make the mistakes and then realise after the assessment they should have put it in, but still don't, and then make further mistakes later on. Just an observation over the years. So be careful. Next problem, people go 4x, take 9x. It's 4x, subtract negative 9x. So you've actually got 4x plus. Remember, 2 negatives make a positive. So it's a 4x plus a 9x, that's 13x. And I've done the subtract. So we're back to divide again. So divide, how many x's in the 13x? You could write it again here, x in the 13x, the x is cancelled and you've got 13. Or you can just go get rid of 1x. X into that is 1 less x, and you've got plus 13. Oh, and before I forget, if you watch other people teaching it, they'll put the x squared there, the minus 3x there, and the 13 there. There's no great need for doing it. Some people would like and prefer that, but some people, I'm still preferring to put it here first. It's about probably 50-50. So x into there was the 13, and the multiply again, so now we're going to multiply. 13x by the x is 13x. Make sure you multiply both. 13 by the 3 is 39. And this is nice because the 39 will subtract to the 39. I still am going to nag about put the subtractions in. That's gone. That's gone. There's 0. 0 means there's no remainder. So no example so far where you have a remainder. This is just ones that factorise nicely. Go back to what I've said over here. Would I be able to divide and simplify that fraction down to something easier? So I can now replace x squared minus 3x plus 13. I can replace that, all of that here, or all of it there, by the x plus 3 in brackets, and by the x squared minus 3x plus 13. And some of you at this point used to say, why do we do this for? And it's like I talk about math is backwards. You learn how to do something before you see the purpose for it. We use this all over the place in terms of doing graphs and calculating details on graphs. It's also about what we talk about with integration later on, and also with basically simplifying fractions. There's lots of uses that you don't see the use for at the moment. So now this expression has become that expression, so I can cancel an x plus 3 there with an x plus 3 there, and I've got x squared minus 3x plus 13. So it was useful to simplify the expression. One other thing it's for as well, if I talk about the function, go back to the original, x cubed plus the 4x, try not to get too much into this, the videos get too long. And I can replace that by, I can talk about it also equals to x plus 3 times by the x squared minus the 3x plus 13. And by the way, my brain instantly goes, can I factorise this further? And I can look at it and say no, because there's not two numbers that multiply the 13 to add up to 3. We could talk about subtracting 3. So add up two numbers that multiply 13, there's only 1 and 13, which would add up to 14, and this is a 3. So if you wanted to go further, you'd have to use the quadratic formula. I hope it helps. If it's helping, please let your friends know.